Hello everyone, welcome back to my channel Prince Automation Destination. So in today's lecture we are going to talk about another interesting interview question, that is parallel execution challenges and how to resolve them. So while giving the interview, we are generally asked like whether the parallel execution is implemented in your framework or not. If yes, what are the challenges that you have faced and how you achieved the thread safety between the multiple threads, right? So while dealing with like parallel execution, we generally need multiple threads to run the test cases in parallel, right? So this is what we are going to cover today from the TestNG perspective. So while working in automation, there are two type of execution. Let us understand one by one: sequential execution and then parallel execution. So sequential execution is to run the test cases one after another, and parallel execution is to run the test cases in parallel so as to achieve the efficiency, so as to quickly execute the test suite. So, while working with parallel execution, we generally come across uh, these challenges: null pointer exception, no such session exception, and this is thread interference. Because uh, while working with the parallel execution, we usually create multiple threads, right, through testng.xml, correct? So when we create multiple thread, as a result of it, multiple driver instances are created, and these started interfering if no thread safety logic is implemented, right? And as a result, like we get uneven results. Okay, so let us quickly try to understand the same. So while implementing the framework, we need a static or common instance of driver. So what are the ways to keep the driver common across the execution, right? So when we want to execute a whole test case, so we need a single driver throughout the execution, right? The same instance. So there are two ways: static driver and then singleton driver. So today we are going to cover from like challenges using static driver and challenges using singleton driver as well. First, we will cover static driver and its resolution, and then we will try to understand singleton, then singleton driver parallel execution challenges, and later resolution. So without further delay, let us quickly jump onto the demonstration. So I have created a very basic TestNG framework, where what I have done, I have created one TestNG XML, I have created one test class, and uh, this TestNG.xml, and we are using a Maven project wherein we are keeping the dependencies. Okay, so in this case, what we are doing, so we have created one login test static and login test singleton, but right now, as we are going to talk about static first, so I'm focusing on static, right? So in TestNG, how do we write the test cases? So I'm assuming that people are aware uh, on how to write the test cases in TestNG. So what I'm doing, I'm using a sample application, that is source demo, and I'm logging into that using the username and password, and then I'm clicking on the login button, and then later I'm asserting products, right? So this is one test case that I have written using the TestNG, right? And then this is the second test case that I have written. So it is again the copy of this same test case, but I have written it like that, right? So I have copied the same test case. So we can say it is first test case and this is second test case, right? Now in TestNG we have one annotation before method which executes before each test case. So at the rate test is nothing but one test case method, right? So when we write at the rate before method, so this particular like code of block of code will execute before each test case. So what we are doing, so we are first launching the driver. If you see, first of all, what we are using this web driver manager to download the Chrome driver, and then after we are initializing the Chrome driver, and then we are launching the source demo. So as I mentioned, this particular block will be executed before this block, right? And before this block as well, right? So first it will launch the source demo, and then after it will enter the username and password, right? Similarly, the same thing is achieved here, and in the after method, that is after each test case, I'm quitting the driver, right? Now, if you notice what I have done, I have kept driver as a static, right? So when I have kept driver as a static, so as I mentioned, like there are two ways. One is static driver and second is singleton. So what we are doing, we have defined one static variable, and then after what we are doing, we are here assigning the value of Chrome driver object to this driver. So once the Chrome driver is instantiated, we are assigning the variable here, the value here, and then we are launching the URL and the same driver, because once the value is assigned here, this particular value is being used here, right? Now let us try to execute this test case in the sequence first, right? So in order to execute the TestNG test case, we usually rely on testng.xml. And if you notice that I have we have this testng XML, and in this testng XML we have this suite, and this is test, right? So I have given it name parallel execution challenges, and then after which class we need to point to. So this is the package that we have given, and then after login test static, right? So this is the class it is pointing to. So if we want to execute this test case, so let us right click on this testng XML and run it. So we will see that first test case executed first, then the second test case got executed. So this is the sequential execution. Now how to do the parallel execution? So for that purpose, what do? We provide parallel equal to methods here, because test cases we want to execute in parallel, and one test case means one methods, right? One method, right? And then after, how many test cases we want to run in parallel? In our case, we have two test cases, so I want to run two test cases in parallel, right? Now if I will try to execute this test case from this testng.xml, what will happen? We will get few challenges. Just observe the same. So you see that two test cases started executing in parallel, right? So you see that they started executing parallelly, and now you see that we got some issues. So for example, no such element exception and other issues. So what is the reason of this? The reason is because the driver is unable to instantiate, or like the driver started interfering, right? So how to like now overcome this challenge, right? So you see that, because when we provided two threads, so what will happen? Two driver instances would be created, one per thread. But what would be happening? So for example, they are able to launch Chrome driver. So maybe driver 1 would have launched this, and driver 2 have started like executing the test cases against this because of the interference. So how to avoid this interference? So to avoid this interference, there is a concept, or there is a class in Java, that is thread local. Okay. So thread local, what does thread local do? So thread local, using thread local, we can store the value of driver, and then we can get the value per thread. Like each thread will store the value, and then after, the same thread will get the value, right? So we isolate the values of variable, right? So in this case it is static, so interference is taking place. So now I'm keeping it as it is. So I'm just now creating the object of um, thread local instance of WebDriver. So how to create thread local instance? So we need to simply enclose this particular class or interface, sorry, WebDriver interface into this thread local driver, and we need to simply pass new thread local, right? So using this, we are assigning the, we have now converted it into thread local driver, right? So we will remove these values once I have done. So the next step is, so in thread local we have two methods mainly, set method and get method. Sorry for the disturbance. So we have two methods, set method and get method, right? So using set method, we will first assign the value of driver, and using get method, we will get the value. So let us see the same, right? So how we will get this? Let us try to understand this. So this particular line we still need. Only thing we need to do thread local driver, the variable that we have created for this dot set. And now I'll simply copy this line of code and put it here, right? So using this I will get the thread local instance, right? When we will get thread local instance, so now what is the next thing? Now the next thing is thread local driver dot get we will use, right? So let us do the same. So how to get this thread local driver, and I'll simply replace everything with this thread local driver dot get. So using get we will retrieve the value that we have set up. So I'm now removing this particular line, right? And this particular variable is also not needed because we have created thread local instance, thread local type of variable, right? So what we will do, we'll simply use this particular line of code wherever we have driver, right? So I'm doing this, and likewise here as well, right? So let us quickly recap what we have done. So we have converted the normal WebDriver instance into the thread local type of instance. So how we did it? By enclosing it into the thread local, and then after we were writing driver equal to new Chrome driver, and we were assigning it to the static variable. But now what we are doing, in order to assign it to the thread local variable, we are initializing the Chrome driver and then we are setting it to the thread local driver, right? So if first thread would have set this value, then the first thread only will get this value, right? So this is how we can like avoid the interference. So now let us rerun it to check that there is no more interference anymore. So you see that two test cases are executing parallelly, and you see that execution is taking place, and now we got the result as positive. So this is how we can avoid the interference, or this is how we can achieve the thread safety, right? In the case of static driver. Now we have I have copied the same class with usage of singleton design pattern, singleton driver I mean, right? So before we discuss about this, let us discuss about singleton design pattern first. So I have created one singleton class. So what is singleton design pattern, right? So as there is a requirement right now that we want to have a single instance of driver throughout the execution, right? And so singleton is a design pattern using which we can have a common object and we can get the single instance. Single instance is nothing but single object, right? Now private. So in order to convert any class into singleton, we simply need to create a private constructor so that no one would be able to create the object of it from outside, right? Because if it would be public, then everyone would be able to create the object of it. Now how to, when we have created the private access, we need to have some provision to create the instance at least once. So for that purpose we will use another concept of Java, that is static method. So static method get instance, right? And now you see that what we have done, we have created a static instance, right? So static method we have created. So static method can be accessed without creation of object, right? Now I am simply creating one reference variable, right? And we will, what is the reference variable? We need this reference variable, and I'm calling it like instance, so you can name it anything. Now I am checking if instance equal null, right? If instance is null, then what we are doing, we are creating the object of no singleton now, and we are assigning it to instance, and then we are returning the instance, right? So I need to replace the return type because it is void, but we are returning something, right? So wherever now let us create one main class as well, right? And psvn. So how we can call this singleton dot get instance, because this is a static method, and this is how we can create the object of it. Now for example, we have some method here, public void test, right, and test, right. So now using this instance, because we have created the object of it and this is a non-static method, so using this we can get the object of it, so we can call it. So if I run it, let us see. So you see that we are able to execute the test case. And if we will, for example, try to write new singleton, we won't be able to write. Why? Because the constructor is private. So when the constructor is private, we don't have right to create the object of it, right? So this is how we can restrict it. And so let us understand it at high level. So first of all, we have created one private constructor so that we won't be able to create the object out of uh, object of it, I mean. And then we have created one static method using which, first of all, this get instance, first time when it will be called, it will check if instance is null, because this is static. So if instance is null for the first time, then what it will happen, it will store the value, right? And as this is static, so it will be stored. So next time when the control will come, and from anywhere when we will call this get instance method, it will check, and this time the instance value would be not null, and in that case the control won't go here, so control will directly come here and it will return the previous instance, right? So this is how we use the singleton design pattern. Now, and in case you want to understand more on singleton design pattern, I have created another series where you can understand the same. Now let us discuss the let us come back to the original problem of driver, right? So in this case, what we have done, so you see that uh, in the previous case, if I talk about in this case, like static one, we were initializing the WebDriver, the static WebDriver, and that we were using. But in this case, how we are using, first of all, we are like let me show you the design pattern that we have implemented. So I have created one singleton design pattern for the driver to return the single instance of driver. So what we have done, we have created the private constructor first, and then after we are getting the instance as like just we discussed, right? Then we are using this set driver method, in which what we are doing, we are setting the driver value, right? And this driver value is defined here, right? And then after using get driver, we are simply returning, right? So we are again setting the static value, like the driver value, I mean, using the static, and we are returning it, right? Now how we are using it, first of all, as I mentioned, using this we created the object of singleton class, and using this set driver, first we will call this particular method and we will set up the instance of this set driver method, right? So this is first time we need to write. And afterwards, like after this line, once we have set up the driver, then the next step is we need to get the driver. So how to get the driver, for that purpose we have written this logic, and we are returning the same driver, right? Whatever we set here. Now you see, we just discussed that this is the method before method which will execute it before every test, right? Now if we will execute this test case, still we will get, if we will execute these two test cases in parallel, we will still get the error, right? Because right now also there is no thread safety. Even though we are using singleton, we will get two threads or multiple threads based on the thread count defined, but we will get thread interference. So I have created another testng.xml wherein I am pointing to this particular login test singleton, right? And again I have provided parallel equal to methods and thread count equal to 2, right? Now when I will run this second case using singleton, we will see that we will again face the challenge. So you see that this time we previous instance, if you notice what happened in that case, like it like two driver got initialized, two browser got initialized. So first driver entered the value in username, second driver also entered the username and password in the same field, right? So this kind of problem happens, right, without thread safety. Now you see that we are again unable to execute the test cases in parallel. So how to like resolve this? So for that purpose, we need to simply go to our singleton class, right? And here also we need to implement the thread local instance. So how to do that? Again, we will use public private thread local and WebDriver, and I'll give it name WebDriver thread local, new thread local, new thread local, right? And what we do, we will again go here as like we did previously, dot set, and I'll put this particular part new Chrome driver as like we did in the previous section for static case. And now the same thing to return this, what I will do, I'll simply use WebDriver thread local dot get, right? And now you notice that first of all we are setting it up, and in order to get it we are using get driver, and wherever the driver was we have simply replaced that with this particular line of code so that we get the driver. Okay, now let us try to re-execute this case. So it should execute the test cases without any challenge this time. So you see that the test cases got executed. So let us quickly recap what we have discussed. So we discussed about the parallel execution challenges and their respective resolution in TestNG. So we discussed about sequential execution, parallel execution. Then we discussed about how we can create the driver instances using static driver and singleton driver. Then we discussed about challenges using the static driver, thread safety related challenges, and then we discussed about singleton thread safety challenges and their respective resolution using the thread local concept. So this is what I wanted to cover as part of current video. I would request you to please like, share and subscribe my channel. Thank you for watching and stay tuned for more such videos. Thank you.